Hey everybody, welcome back. Today we are going to be talking about 5.4, the hypotenuse, not hypotenuse, hypotenuse leg congruence theorem. We also call that HL. Now this is going to be your last triangle congruence theorem that we're going to be talking about in chapter 5. So let's get to it. Today we are going to be using the hypotenuse leg congruence theorem and summarize congruence postulates and theorems. So at the very end, or maybe a little slightly before the end, we're going to go over some of the same congruence theorems that we've talked about already, along with hypotenuse leg. So the very first thing we need to do is we need to write down what hypotenuse leg congruence theorem is. So I know you're going to love this, but please write this down. Alright, it says if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. Go figure. Hypotenuse leg congruence theorem is talking about a hypotenuse and a leg. Remember, what is a hypotenuse? Exactly, that's the angle across, the side across from the 90-degree angle. So if you look at this triangle BAC, AC is going to be your hypotenuse because it's on the opposite side of that 90-degree angle. Awesome. So now that we know what a hypotenuse leg congruence theorem is, let's move on to a couple examples. Woohoo! I hope you're excited. Yes, here we go. First one, notice you have no yellow bar up here, so you lucked out on this one. Okay, so all I want you to do is just kind of follow what I'm doing, and you're gonna do a similar problem on the next one. So it says determine if you can use the hypotenuse leg congruence theorem to prove the triangles are congruent. If not, tell what else you need to know. So the very first thing I'm going to do is I'm going to look at this problem. Okay, I notice that I have two segments that are congruent. Now, I know that they are hypotenuse. Okay, how do I know that? Well, I have a 90-degree angle here, and these two angles, this angle here, this angle here, they are supplementary, which means they add up to equal 90 degrees, 180 degrees. And since I know one is already 90, that means that line is perpendicular. Okay, so I know that they're both hypotenuse. Now, according to the hypotenuse leg congruence theorem, I need not just a hypotenuse, but also a leg. Well, if you notice this wonderful side right here, they share that side in common. Okay, so that side has to be the exact same length because it's shared. All right, so can I use this theorem? Yeah, absolutely I can. And the reason behind that is I have a hypotenuse that's they have the hypotenuse congruent and they share a side. Now think about that property. What property would we use in a two-column proof that would say that side is congruent? The reflexive property of congruency. Don't forget of congruency in that as well. And they share a side. Excellent. So we have our hypotenuse on each side that are congruent. We have our our leg that is also congruent. Because of that, we can use hypotenuse leg congruence theorem. Perfect. This one you do get to write down. And that says triangle, and that is a D there. DCB. That is an ugly C, but DCB. So we want to figure out if angle or triangle ABC is congruent to triangle DCB using only the hypotenuse leg. Don't forget about them, but don't use any other process. Just use the hypotenuse leg theorem. Give her a shot. Alright, so if I look at this, okay, again, I notice my given information is my hypotenuse are congruent to each other. AC is congruent to BD. Those are my hypotenuse. But according to this theorem, I also need a leg. So do I have a leg? Right there. That wonderful leg right there. So BC and BC is congruent to CB. Okay? Or BC is congruent to BC. Now, so is that true? Yes, it is. Why? Well, the hypotenuse is congruent. Are congruent. And if you look at that side, they share that side. And they share a side. Perfect. So they share, well, side. Alright? So they share a side and their hypotenuses are congruent, which means you can use the hypotenuse leg congruence theorem. Alright? Excellent. Good work. Here we go. So on this one, I want you to draw this, and it says there's 3 problems here. I want you to identify the postulate or the theorem that proves the triangles are congruent. So you're going to use previous postulates. So you're going to use things like SAS, SSS, hypotenuse leg, HL, which we just talked about, ASA, things of that nature. You can use all of those in this problem or in this example. So I want you to see if you can do that for each of these. Give her a shot. Alright, so looking at this problem, okay, this very first one, you will notice that we have 150 degree angles, 250 degree angles, a side that is congruent to each other, and that 2 angles that are also 15 degrees. So if we look at this, we drew this a picture, we have angle here, we have another angle right here, and we have that side. Well, if you notice, that side is known as our included side because it's included inside those 2 angles. So when we have 2 angles and the included side, what property is it? It is that beautiful angle, side, angle. Excellent. Okay, next one, if you look at, we have 2 90-degree angles. We have 2 sides that are congruent. Okay, what properties could we use? Well, if we look at this, our 90-degree angles are right here, which means what does that tell me about this side? Well, that's our hypotenuse. Okay, so we have our hypotenuse congruent. Well, if you look at there, look at these. Our legs are also congruent. We have a leg congruent, we have hypotenuse and a leg congruent. Well, we could just use the hypotenuse leg congruence theorem, of course. Awesome. Okay, another way you could look at this, you could also notice that they do share this third side. So if you put side, side, side in this, excellent. That's just another way. So hypotenuse leg, or I'd also take side, side, side. Okay, last one. Now this one's a little trickier. Okay, if you notice we don't know that inside angle, okay, we don't know what that angle right there is. But what we do know is we have 2 congruent sides. Okay, so we have that one side here, another side right here. Okay, we also can say that this third side, is that going to be congruent to the third side? Absolutely, the reflexive property. Okay, it's the same side. They share a common side. So that has to be congruent to itself, right? Absolutely. Okay, so I would take side, side, side. Now, the other thing you could see here, okay, if you look down at this angle right there and this angle right there, they are congruent. What does that tell me about this angle? It is also congruent to this angle over here. What theorem tells me that? I hope you're thinking vertical angles. Vertical angles, absolutely. Yeah, vertical angles theorem. Okay, so your vertical angles theorem allows me to say that that angle is congruent, this angle is congruent to this angle. So because of that, we have two sides. We have the included angle, or where those two sides come to a point. We could also use SAS, a little sass. Okay, awesome, nice work. We're going to try a two-column proof. All right, here's our two-column proof. Yeehaw! I hope you're excited. I want you to give this one a shot on your own and see what you come up with. See if you come up with the relatively the same steps that I do it. There's a couple of that you can kind of mix around a little bit, but remember, one step has to lead to the next. Another step has to lead to the next. All right. Another thing that you should probably do is when you draw this and you're given the information, put that given information into the drawing. Okay, that'll help you visualize it as you're going through your two-column proof. All right, so give this one a shot. Go get it. All right, here we go. I'm just going to set up my thing here, and let's get going. Okay, FAB is congruent to GED. I'm just going to write that step 1. Angle FAB is congruent to angle GED. And that is given. That very first thing is given. All right, step 2, we have ACB, which is this angle right here, is congruent to angle DCE. Okay, so I'm going to put that as step 2. And the reason for that is what? It is also given. All right, so we have another step. Step 3, okay, which is our AC is congruent to EC. AC is this side right here. EC is this side right here. And we're going to put that in our proof with, again, the reasoning of given. Okay, so now we get into the nitty gritty of it. And the way I'm looking at this, okay, I notice that my outside angles of FAB and GED, those two angles are congruent. I also know that the interior side and an interior angle are going to be congruent. Well, I could do multiple different things here, but when I look at this, I notice that because these two angles, FAB and GED, have a supplementary angle here, that makes my job a little bit easier. Okay, so how can I put in my proof that those are supplementary angles? Well, I'm just going to write it. Okay, so my statement looks like this. And you will notice that I put both BAC is supplementary to FAB and DEC is supplementary to GED. Okay, and the reason behind that is the reasoning is going to be the exact same for both statements. So I'm able to cover that step, that statement there of both of those being supplementary with just one reasoning. And that is going to be your definition of supplementary angles theorem. Okay, now remember, because those are supplementary angles, they would add up to equal 180. Okay, so now when we have this, step 5, okay, so because we know that both BAC and DEC are going to be supplementary to the same angle measure, we can say that they are actually congruent. So in our statements, it looks like this. So angle BAC is congruent to angle DEC, and the reason behind that is going to be, well, those are my congruent supplementary theorem. Okay, remember, if two angles are supplementary to the same angle measure, then they have to be congruent. Okay, so now if you look at my drawing, I see here, so I have two angles with the included side that are congruent. Well, that just tells me which theorem am I talking about. Well, I know that my last step is triangle ABC is going to be congruent to triangle EDC. Okay, two angles with the included side in there. Step 6, I am done with angle, side, angle. Now, there's several steps that you could have taken, but this is a correct theorem. If you have something different, show me. I want you to show me tomorrow, because there are a couple different answers that might be correct in this. All right, so please show me that tomorrow. If you have any questions about how I came up with it, again, ask me tomorrow. Awesome. Moving on. Here's the last one of the day. It comes from page 262, number 29, if you want to take a look at it. It states, and the question is, it says, what congruence is needed to show that the triangles are congruent? Okay, so this is going to be any congruent statement that or congruence theorem that we have talked about. So talking about SSS, SAS, AAS, ASA, HL, all of those congruence theorems. Okay, what information do we need to know to show that these two triangles are going to be congruent? Okay, there's several different ones that you could come up with. I will show you the ones that that work the best. Okay, so I want you to give this one a shot and just tell me, what piece of information do I need to know, looking at these, knowing that I have H is congruent to angle K and FH is congruent to KJ. Besides that, what other piece of information do I need to know to ensure that these two are congruent? All right, so looking at this, the very first thing I notice, I have an angle, I have this side. One thing that I'm looking at is, you know what if I had that other angle with the included side in there? So something like angle F and angle J. Okay, is that a congruence theorem? Absolutely. If I said that angle F is congruent to angle J, that would make it congruent by the ASA congruence postulate. Okay, so ASA congruence postulate. Well, let's take a look at something else. Okay, what if we did another theorem? Let's say instead of angle F and J, let's say what happens if we said another piece of information. Okay, something like angle GH is congruent to side KL. Does that make it congruent? Absolutely. Now instead of the included side, we now have the included angle. Okay, so if I said the information GH is congruent to, not angle GH, I want side GH. Okay, side GH is congruent to side LK, or line segment LK. Which postulate is that? When I have the included angle with two sides. That's the exact opposite, which is side angle side. Absolutely. Okay, there's one more that I'm looking at that makes sense. Okay, and this one is going to be, we already talked about angle side angle. We've already gotten side angle side. But another piece, could I use hypotenuse leg? No, hypotenuse leg doesn't work because we don't have a 90-degree angle. Okay, think about side, side, side. Could I use side, side, side? Well, I could, but I would have to write two pieces of information. It might take a little bit longer. Okay, right? And I would need to make all of those sides congruent. How about our last one? Angle, angle, side. Could that work? Yeah, absolutely. We have this angle, we have a side, but we need that opposite angle of that side. Okay, so if I look at that and I make angle G congruent to angle L, that is our angle, angle, side postulate. So in that way, you can use angle, side, angle, you could use side, angle, side, or you could use angle, angle, side, and only use one piece of information instead of side, 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 where you would need two pieces of information to make those congruent. All right? Awesome. Well, we're going to get going. That's the last one that we have for today, so lucky you. A little shorter of a video, I hope. Cross your fingers. I don't know. All right. I'll see you tomorrow. Have a good day.